Alright, hi guys. So the next little bit of probability we need to look at is expected frequency. Now when we're talking about expected frequency, it sounds kind of confusing, but it's really not. It's something that's quite intuitive. So when we're looking at expected frequency in an event, it is the number of times that you expect that event to occur given that it's a certain probability. And probably the best way to think about this is with an example. So if we roll a dice 600 times, and now most of you can probably do this in your head because it's just common sense, but there is a formula to work it out. So if you roll a dice 600 times, how many times would you expect to get a 5? So I think everyone could probably work that out, that you would expect 100 5s. And that's because you would expect around about 100 of each number if you're rolling 600 times. Now, to work this out in a bit more of a mathematical way, we know the probability of getting a 5 is 1 out of 6. All right, so then to find the expected number, and for expected number we write e of x, that's our expected number, that is 1/6 times by the number of times you do it, which is 600 times, so the number of times we roll the dice. Okay, so that's 1/6 times by 600. Now again, if you want to use a calculator, go for it. I'll get mine up so you can, sorry, it's going to be TI Smart View. Where's my Smart View app? There we go. Okay, again, remember you're going to have a calculator in your exam, so I'm happy if you want to do this on your calculator for the moment, but if you don't, that's also fine. So just wait for this to arrive. There we go. Okay, so I'm going to get my fraction button up. So I'm going to do that 1/6 times by 600. Now a 1/6 of 600, that's obviously 100, which is what our answer is going to be. And again, you should be able to do that in your head without using a calculator, but it is there if you need it. Okay, so that's 100 times. So we would expect, let's write, therefore, we would expect 100, not 500, 100 5s. Now, that doesn't mean that if you roll the dice 600 times, you're exactly going to get 100 5s. It does not mean that at all. In fact, on here, I've got a dice roller. Where is it? Roll the dice. Okay, so if I roll this, now this is going to roll 101 times. Sorry, we'll do 600 times, so 50. It's 100, 150. 200, it's going to roll 601 times, but that's okay. 300, 350, 400, 500. Okay, there you go, 600. Now you can see that's not all exactly the same because we actually have here 113 3s and there's slightly less 4s and everything else. So that doesn't mean that they're all going to be exactly the same and you're going to get 100 of each. But what it does mean is that's how many you expect to get beforehand, and that's the really important thing. It's not what you actually get, it's what you expect to get. And this is something that scientists use a lot in doing predictions with probabilities. Alrighty, next example. There is, and this is your formula by the way as well, so this is what you definitely need to copy down, so you need to have that. So the probability of an event times by the number of trials you have altogether. Okay, example 2. There is a 2 out of 15 chance that it will rain on the UK on any particular day in July. If there are 31 days in July in total, on how many days would you expect it to rain? Okay, so we know the probability of rain is 2 out of 15. Okay, that means the expected number of days for rain is 2 out of 15 times by 31, because that's how many days there are in July. And then we're going to, I'll just be quick out of this, escape, yes, quit, yes. Okay, so we're going to have 2 out of 15 times by 31. All right, and that gives us 62 out of 15. Now that doesn't really tell us much at all, so we want to convert that to a decimal. Your calculator will do this differently. You want to use that S to D button that you have. So we convert it to a decimal. And we get 4.13. So 4.13. Now, there's no really such thing as having 1/3 of a day. So I'm going to round that and I'm going to say we would expect approximately 4 days of rain. There you go. Okay, cool. Next one. This is the last example. So, got some numbers there. Miss Hoadley is very bored in ISO and counts the number of red cars that go past her house one day. 10 out of the 50 cars that pass her house are red. So my probability of a car being red is 10 out of 50, which is the same as 1 out of 5. All right. The next day, 40 cars go past my house. How many of those that we expect are not red? So now the next thing we need to do, if we know our probability of red is 1/5, that means our probability of not red is 1 minus 1/5, which is 5 out of 5, minus 1 out of 5, okay, which is 4 out of 5. And again, most of you will have done that in your head much quicker, but there you go, there's the full working. And that's relating back to what we did earlier on, so that's really important. Now, my expected number of red cars is of not red cars, is 4/5 times by 40, okay, which is 32. So I would expect approximately 32 cars are not red. There we go. All right, that's it for today. Go on and do the next My Maths activity and then come back, and if you get time, you can finish off the rest. Okay, alrighty. Hope you guys are doing well and have